Alright, students, this is the lesson record for the e-learning package for Chapter 1 Experimental Chemistry. So we are looking at part 1 of the topic because the topic is actually quite long, and we'll be looking at physical quantities and apparatus first. Okay, but before that, shall we take a look at what are the learning objectives for the topic? Okay, so you'll be learning how to state common physical quantities measured in the chemistry lab, and you will be naming appropriate apparatus, okay, for the measurement of time, temperature, mass, and volume. And we'll be looking at these apparatus, burettes, pipettes, measuring cylinders, and gas strange. After which, we'll be looking at next section in terms of collection of gases and drying of gases. So, just a brief introduction. We know that in any science experiment, okay, apparatus is a very important part of it. Okay, so a scientist usually will need a lot of laboratory apparatus and instruments to carry out experiments. And in chemistry, these measurements are often required. So we are going to take a look at some of the apparatus and their uses. Okay, first up, can you turn to page 2 of your notes, and you will be able to see one page containing many pictures of different apparatus. All right, you can pause the video right now and try to identify as many laboratory and apparatus you can and name them. All right. Now let's take a look at the laboratory apparatus that you have named, all right? And we'll be going through their names right now. Okay, so the first picture that you see is actually an electronic mass balance. Okay, the second one may be slightly more difficult to identify. Some students may actually say that, oh, it's a bowl, but it's not. In chemistry, we call this a evaporating dish. Do be mindful about the spelling of evaporating. Okay, there isn't a U in front of the R. Okay, so it's not evaporating, it's evaporating. Okay, the next picture, we are actually looking at a gas strange, followed by most of you should be very familiar with this instrument. This is a thermometer. Okay, the next instrument is a test tube, or it could also be used to represent a boiling tube. A boiling tube is actually a larger or fatter version of a test tube, okay, which you will be seeing in the lab. The next apparatus, electronic stopwatch, right? So have you managed to achieve most of the apparatus? Are you able to name them correctly? Okay, if you have been able to do that, that's very good. That's a good start. But even if you can't, no worries. Okay, we are actually that's the purpose of going through it. All right, let's take a look at the next 6 apparatus. This is a beaker. The next instrument should be pretty new to most of you, so you will actually, this is probably your first time encountering it. Alright, I will not be surprised if you don't know what it's called. It's called a burette. Okay, I will explain more later on. This is a measuring cylinder. The next instrument, the next 2 instrument actually, or apparatus, is actually something that you're probably not familiar with as well. This is a pipette, and this is a pipette filler. Right, more will be discussed later on. Okay, this is a filter funnel. Right, you cannot just write funnel, it's actually a filter funnel. And the last is a conical flask. Okay, so do fill in all the names of the apparatus and check against your answers. Now, with all these apparatus being introduced, shall we dive in deeper and look at the different physical quantities that we need to measure in chemistry? What are some of their SI units in which they are being measured in? And once measured, how should we present the values, okay, that we have collected? Okay, in terms of what kind of accuracy. right? So if you turn to page 3 of your notes, we will be covering the content on page 3. All right, so let's move on. So the first quantity is actually time. All right, so a lot of it you have covered in lower sec already or in primary school. The SI unit for time is second. This is the symbol. Okay. Then after which we can also use minute or hour to represent them. Okay, and you should be pretty familiar with these two relationship. 1 minute equals to 60 seconds and 1 hour equals to 60 minutes. So actually 1 hour will be equals to 60 times 60, which is 3,600 seconds. Okay, so the apparatus that we use to measure time, besides the normal clock that we use in our daily life, in the lab, we will be using an electronic or digital stopwatch. Okay, this one over here. Now, I just want to bring your attention to this particular instrument. Okay, the analog stopwatch is actually not commonly used in the laboratory. We use the digital stopwatch more frequently. Now, I'm going to blow this picture up, okay, so that you can have a clearer look at it. So you can see there's actually a second over here, and it represents that we are looking at a timing of 12 seconds. Okay, the two digits after that is telling you that this is a 12 second, 72 over 100. Okay, or rather 12 and 72 over 100 seconds. Okay, now do we record such values in our table, or when we are doing experiments in the laboratory? No, we don't do that. Okay, now this value 72 out of 100 second is way too accurate for us at this point of time. All our readings, right, will be recorded to the nearest second. So if I want to record this current value that I see on the electronic stopwatch, okay, as my result, I will actually record it as 13 seconds. Okay, since the value over here 72 is higher than 50, okay, so we will actually round up the value to the nearest second. So from 12 it becomes 13. Okay, then the next set of numbers here will represent minute followed by hour. Okay, so that is how you read the stopwatch. So you get a chance to try this out in the laboratory very soon. Okay, so that is time for us. Okay, let's move on. Temperature. Temperature SI unit is Kelvin, and this is the symbol. We normally use degrees Celsius to measure temperature. Okay, so what is the relationship between Kelvin and degrees Celsius? Okay, the relationship is actually shown here. Right, so for example, currently if let's say I'm in a room that measures 30 degrees Celsius, okay, so it's I would say a pretty warm weather, 30 degrees Celsius. So this value is 30. If I were to add it to 273, that will give me the value in Kelvin. Okay, and that would be 303 Kelvin. Okay, so that is how we actually calculate and interconvert the two of them. You won't really do this very often, okay, in chemistry. It's just more for your knowledge to be aware of it. So how do we measure temperature? What is the right instrument or the apparatus to use? That's right. I think you're all very familiar with thermometers in general. There are many kinds of thermometers. You use that to measure your temperature as well if you are feeling unwell. So nothing surprises you. Okay, but I would just want to bring your attention to this. How do we read off the value that we see in a thermometer, a typical thermometer? So if I were to enlarge this value over here, to show, all right, how the reading of this value. Okay, let's take a look carefully. When you're reading a thermometer value, you should look at the two for the difference between the two values that I have circled, 40 and 50. There are in total 10 divisions between them. Okay, this will mean every 10 degrees Celsius, there are 10 divisions. Each division would be 1 degree Celsius. Okay, so this is a 41, this is a 42, 43, 44, so on and so forth. So it's quite simple. So this particular value that you see over here actually lies between 42 and 43. So if I were to record it, I will record it as 42.5 degrees Celsius. I'm able to read in between. Okay, let me enlarge this. I'm able to read in between these two temperature readings. Okay, so for thermometers, right, they are able to give us an accuracy of the nearest 0.5 degrees Celsius. Okay, all right, so there are some thermometers whereby it's calibrated even more accurately, but the current values that I show you, or the current accuracy that I show you, is the general ones that we see in the laboratory. Okay, in our school laboratory. So that is a thermometer for you. Let's move on to mass. So mass, SI unit kilograms. It can also be measured in grams or milligrams. So this is their relationship. What is new, probably for you this year, is this quantity called ton. All right. So ton is actually a quantity used to measure large masses, very large mass. 1 ton is actually 1,000 kg, which is 1 million grams. Okay, so sometimes I actually ask my students, do you know what is the heaviest noodle on earth? Any guesses for that? All right, the answer is wonton mee. Okay, because 1 ton is 1 ton. All right, so that will be a very heavy noodle. All right, let's move on. So what do we use to measure mass? We can use more commonly an electronic mass balance. All right, beam balance is not really used that often. Okay, so electronic mass balance is the one that we use in the lab. How accurate will it be? Okay, let me just blow this up to show you. So you can see from this particular picture, the electronic mass balance is actually measuring to 2 decimal point. This is actually the one that we use in our laboratory. Okay, some electronic mass balance, they are unable to give such a high accuracy, so they may end up giving us only an accuracy of 1 decimal point instead. Okay, but this is what we have in the lab. All right, so it could be 1 decimal point or 2 decimal point. Okay, let's move on. Next, length. All right, length, SI unit meter, you learn that in math or in physics as well. Okay, but other measurements will be milliliters, millimeters, centimeters. What is probably new to you is this unit. It might be the first time you are looking at it. Decimeter. Okay, so how is decimeter related to the rest of the unit? 1 meter is equals to 10 decimeter. So later on, you will discover that 1 meter cube, okay, will be equals to 1,000 decimeter cube. Okay, so that's in terms of volume over there. All right. And we can also see from this relationship that 1 decimeter equals to 10 centimeter. So subsequently, you will realize 1 decimeter cube will be 10 times 10 times 10 cm. So that will give us 1,000 centimeter cube as well. This is going to be a very common conversion you will learn in your 2-year course in chemistry. All right. So let's move on. So what apparatus will we use to measure length? I think this is quite obvious. Measuring tape, meter rule, etc. Okay, or ruler. In terms of the accuracy of the apparatus, it really depends. So certain ruler, they may give you individual division, but I think most of the time you can see that between maybe 0 to 1 cm, there are 10 divisions. So the accuracy is usually like 0.1 cm for a normal ruler. Okay, but it differs from ruler to ruler. Okay, now let's move on to volume of liquids or volumes in general first. Okay, so the SI unit for volume is cubic meter, or I think you all like to call it meter cube, right? Then other units will be cubic centimeter or cubic decimeter, which I've talked about just now. So I will need you to actually take note of this conversion, where 1 dm cube is equal to 1000 cm cube. It's actually in your notes, but we'll just put a star for this relationship. Okay, so what are some of the apparatus that we can use to measure volume? Now, there's actually a large array of apparatus. We have a measuring cylinder, a conical flask, beaker. This is called a volumetric flask, okay, which you will probably use in JC. This is another conical flask. Then we have one here called the pipette, and then you have the burette. And I'm going to be elaborating on each one in detail. Okay, so let's move on. Okay, so here I have conical flask and beaker. Okay, why do I show them in the same frame is because these two apparatus will only give you approximate volumes. Okay, so the whatever volume they measure, they are never highly accurate. Okay, let me just explain to you why is that so. Now I'm going to blow up conical flask, and you take a good look at the marking. Can you see there's 200 here, and then it's just one line, and then there's 250, and then it's another line. What will happen if my liquid level is here? Would you be able to tell what is the exact volume? You realize you can't. And the calibration of this 250 is actually very not that accurate. So that is the reason why we do not use conical flask, or even later on you'll see beaker for measuring accurate volumes. Okay, it's just for approximate volumes. Beaker as well. Okay, let me blow this up. So you can see there's a 100 reading, there's 150. So I know this is 125 cm cube. But anything that is in between, we will have no idea what is the exact volume. Okay, so conical flasks and beakers, honestly, very, very approximate value only. Okay, not our preferred choice. We may have a slightly better instrument, okay, called the measuring cylinder, to help us measure volumes. However, it is still only able to give you approximate volume, but slightly better compared to conical flask and beaker. So I will explain why right now. Okay, so first up, okay, if I were to give you a sample of how the readings in a measuring cylinder will look like. Okay, so this is giving you an idea. So you can see this value is 20, this is 30. In between, once again, there are 10 divisions, and that is a total of 10 cm cube. So once again, every division means 1 cm cube. So this is a 21, 22, 23, 24, 25 over here. So if I want to read off this value, let me enlarge it. Okay, there are 2 points of reference that I need to take note of. Okay, and I'm going to try to circle it in red. One point of reference is here, the other point of reference is here. Okay, now how do we actually read this reading, okay, of the measuring cylinder? This curved line is what we call the meniscus. Okay, so when you take reading, right, you should take at eye level from the bottom of the meniscus, so over here. Okay, from the bottom of the meniscus. So this reading should be read as 24.0 cm cube, the 0.0 need to be written because if my value is like that, okay, if my meniscus look like this, I'm going to draw another meniscus over here. Okay, I'm going to try my best to draw. Let's say my meniscus is like this. Okay, do you realize that the bottom of meniscus is in between these two numbers, 29, 28? So I can actually read the value of the liquid in between 1 cm cube. So I can read it up to the nearest 0.5 cm cube. Okay, so I should show this accuracy by recording it as 28.5 cm cube. Okay, so but the last digit, right, is only either a 0 or is a 0.5. You can't read anything more accurate than that. So you cannot report answers like 28.1 cm cube, 28.2 cm cube. You won't be able to detect that. Alright, so that is measuring cylinder for you. Right? So let's move on. Then do we have, so once again, since this is only giving you an approximate reading, do we have better apparatus for measuring volumes? Yes, we do. Okay, so this is what I've already briefed you earlier on. You should always take readings eye level from the bottom of the meniscus. But if the meniscus is actually upward curving, in the case of mercury, then you should just take the top of the meniscus. Okay, otherwise this is the one that we usually follow. So back to what I was saying, do we have apparatus that measure very accurate volumes? We do. Okay, there are two of them. The first one is actually the pipette. Okay, so this apparatus, let me just blow it up. Okay, is called a pipette. You will get a chance to try it, to handle it in the laboratory. Okay, and when you get the pipette, right, always look at the center of the pipette, which I call it the bulb. On this bulb, you'll be able to see a big number. Okay, on it, this number tells you the capacity that the pipette is able to measure. And if let's say this number reads 25, it will mean this pipette is able to measure an accurate volume of 25.0. How does it do it? You will need the help of an apparatus known as a pipette filler. Okay, this is how a pipette filler looks like. So you are going to use this pipette filler to actually draw liquid into the pipette, right? And when the liquid is filled up to this section, okay, let me just color to show all of you. Okay, so let's say I use green. So when you start to draw liquid all the way from the bottom, all the way through the bulb until it reaches, oops, I think I exceeded a little bit. Let me just erase it off. Until it reaches this point. It's not erasing, okay, never mind. I will just point it to you. Until it reaches this line, this thin little line, the entire volume of liquid, which I'm actually boxing up right now in green, okay, is actually 25.0 cm cube. Okay, so that is how the pipette is able to give you an accurate reading. So this instrument is calibrated under very specialized condition to ensure that the volume is very, very accurate. So it is clearly more expensive than other apparatus as well. Okay, so there are many different kinds of pipette. They can come in volumes of 10.0 cm cube. They can come in volumes of 20 cm cube, 25.0 cm cube, okay, or even 50, but the most common one that we use in our laboratory will be 25.0. So you need to be on high alert for this number over here. And to show that it's accurate, is an accurate reading, we must reflect it through the decimal point. Okay, so that is a pipette for you. So what is the second instrument that also gives us accurate volume? It's called a burette. Right, it's called a burette. And this is a simple picture just to show you how a burette look like. Okay, now I'm going to blow this up. Okay, just to show you. The burette is actually very special because it's an instrument whereby the value of 0 starts at the top of the instrument. Then usually it will have a maximum capacity of 50 cm cube. Okay, the burette is very highly accurate. Okay, it is able to give us accuracy up to the nearest 0.05 cm cube. Okay, so how does it work? So this is what I'm going to do. I have actually 2 screenshots of burette readings. So just to show you, let's look at the one on the left. Okay, here you can see this value 7. This value is 6. So it's quite interesting because the smaller number is actually at the top of the apparatus. I will talk more about it later on, why is it calibrated like that. But what I want you to notice is the difference between the two is actually a 1 cm cube. But there are 10 divisions. So that will imply every division is a 0.1 difference. So this is 6.1, this is 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9, so on and so forth. Okay, then do you agree you are able to read midway of the 0.1 cm cube? That is the reason why I say the accuracy is 0.05 cm cube. I'm able to read midway of 0.1. Okay, so this value that you are seeing right now, right, I would say is closest to 6.65 cm cube. This will be the closest that it is very close to this middle line over here. Okay, so that's how we actually read it. Now, so your burning question might be, why is it that the burette is calibrated such that the smaller values are at the top, the bigger values are at the bottom? It's because liquid actually exit from the burette from the bottom. So, if you actually allow liquid to flow out from the burette, then you'll be able to get an increasing value to see. Okay, so you'll get a chance to try out the burette in the laboratory as well. Okay, so shall we look at the reading over here? Okay, this is once again a burette reading. Okay, then you can tell this is 25 and 26, so the value is between 25 and 26. It must be a 25 point something. Okay, so since each division is a 0.1, so this tells me that this is 25.1. Then if I continue, I would know this is 25.5. The bottom of the meniscus is touching 25.6. But we cannot write our answer to 1 decimal point. Burette reading should show that it is accurate up to the nearest 0.05 cm cube. So 25.60 is our answer here. Okay, so that is how we read burette readings. So I hope it gives you a better idea, a clearer idea of what all these instruments mean. So in summary, if you see the word accurate, okay, and they ask you to choose apparatus, you have only 2 choices: burette or pipette. How do I know when I will choose pipette? If you see the magical number 25.0. Okay, this is the telltale sign. Go for pipette. Okay, any other value, burette will be a better choice. Okay, so burette can give you a large variety of values, spanning from 0 to 50, but pipette gives you only a fixed volume, okay, according to how the calibration of it, which is usually 25.0 for our syllabus. Okay, the last instrument is actually an instrument to measure gaseous volume. So I think most of you are very familiar with that. We can actually measure gaseous volume by using what we call a gas stream. Okay, so this is how a gas stream looks like. Okay, so with that we have cleared physical quantities, SI units, and also different apparatus used to measure different physical quantities. Okay, so you can actually spend a bit of time to just try out the questions on page 4 of your notes, right? And then we will be discussing it in class.